see today. So what we have is axis in terms of y. So normally we have our function y in terms of x. So y equals to blah blah x. And now if we give a function in the way that x is in terms of y and ask us to find the gradient, what we can do. So you can still sketch the graph, like make vertical axis becomes y-axis and horizontal axis is the horizontal is the x-axis. I can still sketch it. The graph still exists. But what's the quickest way to find the gradient when we given the form x in terms of y? Okay, so that's what we're going to talk about today. So I think it's the idea for chain rule as well. But if you can just remember dy dx is 1 over dx dy, that will be really handy. Okay, so that's basically what we talk about today. So the dy dx equals to 1 over dx dy. Like first thing is your gradient of the dx dy value cannot be 0 because if it's 0, I have 1 over 0 and it doesn't make sense. So this is the most important thing we're going to learn today. So 1 over dx dy gives you dy dx. Anytime, any question, if talk about gradient, okay, if I talk about gradient, that is refers to dy dx. So it doesn't matter what is the question. If ask you what's the gradient, it's asking you to find the dy dx value, not the dx dy. Okay, so dy dx always means gradient. So that's the gradient. So this is the first derivative. If I think if you know, you will have second derivative as well, right? If you did something again, that's second derivative. You did the first time and then differentiate that again, so you have second derivative. This property only works for first derivative, doesn't work for second derivative. So d squared y and dx squared is not equal to 1 over d squared x and dy squared. So that doesn't work. So second derivative doesn't work. So I will just write it down. Like we'll talk about that more later when we talk about second derivative. But I'll just write it here. That is not equals to 1 over d squared x and dy squared. Yeah, so that's different thing. So you can't y give you x in terms of y. You can't differentiate twice and then flip it and say this is the second derivative. So I will talk about second derivative later, but you just need to remember this only works for first derivative, but doesn't work for second derivative. And you can see the notation. I think it makes sense why it doesn't work. If you think this is the numerator, this is the denominator, 1 over it, just flip it and you have dy dx. But think about this. Second derivative notation is different. The square is on d, so d squared y and dx squared. That's the notation for second derivative. And if you flip it, obviously you don't get that. That's not the same looking at that one. So the second derivative, that's why if you just think about the notation, that's why it doesn't work. So this is d squared x and dy squared. If you flip it, you won't get the same thing. And you won't get the same thing. So that's why the second derivative doesn't work. Not really mathematical way, but if you just look at how it looks like, when you flip it, it won't be the same. Okay, so that's why second derivative is not true. Okay, so well, it's not much to talk about for this topic. Like if you want to see the first one, given that x equals to 5y plus 2 cubed, now it's x in terms of y. I will find dx dy. So the only thing I can find now is dx dy. I will differentiate x relate to variable y because y is my variable now and x is the subject. So it's the dx dy. So d single on one side over d the variable. So variable y. Okay, so let's have a think. What's the differentiation for this one? What's the derivative? 3, 5, 5 plus 2, 2. And that's 15, 5y plus 2 squared. That's my dx dy. So it's easy to find dy dx. Well, you may ask me why I'm interested in dy dx. Because that's the gradient. If I was to talk about gradient, dx dy doesn't help. Must be dy dx. Okay, so I want to find gradient, that's dy dx. So it's 1 over 15, 5y plus 2 squared. Okay, question. when x equals to 27, what you're going to do? Find the gradient at the point x equals to 27. So what is 27 equals the actual equation? So 5y plus 2 cubed. And then 5y plus 2 is 3. 5y is my 1, and y is 1 over 5. So I will sub 1 over 5 into the dy dx function to get the gradient. So your gradient is actually in terms of y, not in terms of x. So you will sub 1 over 5 into dy dx to get the gradient at x equals to 27. So I have answered the first one. Well, I don't really need the substitution thing. Like this will be the answer. I find dy dx in terms of y already. How I can find dy dx in terms of x? Well, instead of rearrange the equation, what's the quickest way to get the answer? Like, yes, I can rearrange it to make y to be the subject and substitute in. That's it. Inverse. No, like, I mean, yeah, we can do inverse, but what's the quickest way to rearrange it, like, to. So what I want to replace is this part, right? This part involves y. How I can make that equivalent, how many x that equivalent to? So the equation we have is x equals to 5y plus 2 cubed to the power of 2. That's when I circle this to the power of 2. How I can quickly make that equivalent to x? What power I should put on? 3 on 2 or 3? Because we also cancel the 3, so denominator needs to be 3. Okay, so if I do that, so my left hand side will be x to the power of 2 on 3, and right hand side will be just what I need to replace. Okay, so to the power of 2. I can rearrange to make y to be the subject, but it's just too hard to do that. Okay, it takes a long time, and I need to sub it back to rearrange it. So dy dx now is just 1 over 15 x to the power of 2 over 3. And if you want to put negative indices, you can do that as well. Okay, do we have any questions? No? Okay. If no, can I just have a look at example 5? I'll skip example 4. You can do that by yourself. I'll just do example 5, and that's it for today. Okay, show that the graphs of x equals to y squared minus y. Okay, my first question is, how do you sketch x equals to y squared minus y? What's the graph looks like? Oh, I think you should know what the graph looks like. Which way? So what graph flip 90 degrees? The problem go you way this way, 90 degrees right. Okay, so how I can sketch it? What's the key points, key feature? 0 and 1, and turning point. Well, I will make x equals to y bracket y minus 1, and then the graph should be like that. Just sketch it on your graph. Like sketch it. Try to think about the shape of the graph. typo should have something looks like that. If you finish, you can have a look. Well, if you currently see it, you can just go to fraction rule. You just look at this way. So vertical x-axis becomes the x-axis. Well, actually should flip the page from the back to make this the positive y-axis and then the horizontal x-axis. So actually you should flip the page and then look at inside from this way. Okay, so this way. This is the positive direction. That's the positive direction. Okay. But if you can already sketch it, like that's fine. Alright, so I have this graph and y equals to half x plus 1. I have 0, 1, I have intersection at 0, 1, and I should have negative 2 and 0 somewhere here. Okay, there will be a line, something like that. Intersects where x equals to 2. Okay, and find the coordinates of this point. So we will make x equals to a half. Well, actually, I can rearrange the top one to make 2y equals to x plus 2 and x equals to 2y minus 2. I really just don't like fractions. So I make x to be the subject. So I'll have y squared minus y equals to 2y minus 2. Y squared minus 3y plus 2 equals to 0, y minus 1 and y minus 2 equals, sorry, that's y equals to 2. Intersects where y equals to shouldn't be x. I think that doesn't work. So typo should be y. You, yeah, like I think, wait, just solve it. I think it won't make a difference. No. It's 2, coordinates 2. So x equals to 2 makes sense. Now if you just solve it, that's y equals to 1. And that's y equals to 2. And it needs to work for x. Yeah, so x equals to 0. And this x equals to 2. So it is x equals to 2. Well, if you make y to be the subject and solve it, so you will have x solved first and then y. So you solve y first and then sub in. I can't sub in, like, show that question must be you work it out, not you use the answer directly to show like in that way. It's too easy. You just think that it's too easy to get the mark. Okay, just repeat again. Show that question. You shouldn't just sub things in the answer. So ask you to show x equals to 2 is the intersection. Means you find the intersection and you tell me that's 2. Okay, so you find the intersection first. And the intersection you find out must be 2. So that's actually telling you whether you get the right thing or wrong thing. But it doesn't mean you can use it. You can't use this answer. So solve it. So I have intersection like at 2, 2 somewhere here and also the other one here. So if you connect that, that's the linear. Okay, the next one is a little bit tricky. Find correct to 2 decimal places the angle between the line y equals to half x plus 1 and the tangent to the graph at the point you find in A where x equals to 2. So the coordinates is 2, 2. What's the gradient at that point? At point 2, 2 at the kind of reverse problem. Yeah, x equals to y squared minus y. So dx dy equals to 2y minus 1. And then we have dy dx equals to 1 over 2y minus 1. So flip it. So when x equals to 2, y equals to 2 as well. So dy dx equals to 1 over 2 times 2 minus 1 So if you want to find gradient, that must be dy dx. Dx dy doesn't work. So that's 4 minus 1, 3. So a third. How I can write the equation of tangent? Yeah, you can use that one. So what's the other one? I can write straightforward. y minus what equals to, I think it's enough hint. Y minus 2, y minus y1, so 2, 2 is on this line. So you find in the tangent, so that's the graph. You find in the tangent at this point. So this point will be on the linear. So 2, 2 is the point on the linear. So y minus 2 equals to a third gradient times x minus x1, so x minus 2. So y equals to a third x minus 2 over 3 plus 6 over 3. That's a third x plus 4 over 3. So I have two linear, y equals to a third x plus 4 over 3. That's the tangent. And I have y equals to a half x plus 1, and that's the linear. How do I find angles in between the two linear? Well, I think you mix up like two steps. Tan theta. So if I roughly sketch those two graphs, so this is a flatter graph, so it's a third x plus 4 over 3. And if I have a little bit steeper graph, that's a half one. Okay, that's a little bit steeper. Let's say that's, well, it's not really a half, but let's say that's a half x. Well, I know like not really looks accurate. It should be a little bit flatter that way. Which angle I'm looking for? That's the angle I'm looking at. What's this angle? Give me an expression for that angle. What's gradient means in linear? Arctan of half. And how about this angle? Arctan of a third. Tangent theta equals to gradient. Everyone remember? Tangent theta equals to gradient. So you tan inverse the gradient should give you the angle. Yeah. So for linear, tangent theta equals to gradient. So how you can work out the angle theta here? How you can work out the angle theta? Do you know the exterior angle thing? So yeah, you can simplify your answer. When you simplify your answer, Harris, it should be the same thing. Yeah. So exterior angle is the outside angle is the sum of the two inner angles, not next to it. So exterior angle is the sum of those two. So theta plus that gives you that. So that minus that gives you the theta. And you put that into the calculator. Make sure it's degree mode or you convert it into degree later, and you should have your answer correct to 1 decimal places. Question? Where do you learn the angle? Can I just have a look at the formula later? I think it might be a rearranging way of things, but I haven't really used that formula at all. Like I normally sketch the graphs and see which angle we're looking at. And normally it's the tan inverse of one angle minus tan inverse of another angle. If it's over 90 degrees, I'll use 180 to minus that angle to give the smaller angle. That's what I normally do for that. I'll have a look at the formula and see why it works. All right, everyone, do you have any questions? No? Then you can work on your exercise.